Hi everybody and welcome back to the channel. In today's video, we'll explore how to determine if two lines are parallel based on their equations. We'll review the concept of the angular coefficient or slope and see how it helps us identify parallel lines in the Cartesian plane. After the theory, we'll apply what we have learned with a practical exercise to solidify these concepts. Let's get started. Let's consider two lines S and T in the x-y plane, which are not perpendicular to the x-axis. Their equations are respectively y equals mx plus q and y equals m1x plus q1. Now, a line R passing through the origin and parallel to S has equation y equals mx, and similarly the line R' passing through the origin and parallel to T has the equation y equals m1x. If it's not clear why a line passing through the origin and parallel to another has this kind of equation, please refer to the link in the description. Let's suppose line S and T are parallel. Therefore, the two lines R and R' must coincide, because there is only one line passing through the origin that is parallel to the two parallel lines. As a consequence, it must be that M equals M1. Conversely, if M equals M1, the two lines y equals mx and y equals m1x, both passing through the origin with the same angular coefficient, must coincide. Since S and T are parallel to the same line, they must also be parallel to each other. It follows that two parallel lines, which are not parallel to the y-axis, have the same angular coefficient, and conversely, if two lines have the same angular coefficient, they are parallel. We can therefore write S parallel to T if and only if ms equals mt. So for lines parallel to the y-axis, the angular coefficient is undefined, and these lines have equations of the form x equals h And if you want to review these concepts, please refer to the video on lines parallel to the axis that I leave in the description. Now let's put the concepts we just learned into practice with a simple exercise. Consider two lines, R, which is 2x plus 4y minus 3 equals 0, and S, which has equation y equals minus 1/2 x minus 7. So, if we consider R and we solve for y in its equation, we find for y equals 3 minus 2x, y equals minus 2/4 plus 3/4. We can see that the angular coefficient here is -1/2, which coincides with the angular coefficient of S. So we can see that both lines share the same angular coefficient or slope, m, and therefore they are parallel. Thank you for watching this video. I hope it was helpful. If you'd like to learn more about these topics, please let me know in the comments. Keep practicing and see you next time.